Set the balance equal to 0 and measure the empty instrument. Then add water to your instrument. When measuring the volume of the water or solution, you'll notice a meniscus forming. A meniscus is a curve at the surface of a liquid in a container. It occurs due to surface tension, in this case because the molecules of the liquid are more strongly attached to the container than to each other. Because of the meniscus, to get an accurate reading of the volume of the liquid, you must read the measurement at eye level and from the bottom of the meniscus. Then measure your instrument and the solution, in this case water, to find the mass. You'll find the final mass of the solution by subtracting the mass of the container and the liquid by the mass of the container. When you're done with the solution, you can pour it down the sink, as in this case it is just water. You will first start off with a beaker, and then you'll measure the mass of the beaker by itself. Using a different container containing water, draw up the water using a pipette. You can see a meniscus in the pipette like you could see the meniscus in the cylinder, which is why you'll need to read the volume at eye level. Make sure to read the volume by reading the bottom of the meniscus. Once you have recorded the volume in the pipette, release the water into the empty beaker. Then measure the mass of the beaker with the water that you took up with the pipette. You can find the mass of the water that was inside of the pipette by subtracting the mass of the beaker with the water by the mass of the beaker. You will repeat this procedure at least 3 times. In order to find the density of water, you will divide the mass of the water by the volume of the water. You will then need to get an average of the 3 trials for both the pipette and the cylinder, and respectively find the standard deviation of both of them. The equation for finding standard deviation can be found in the beginning of your lab workbook. You will need to work with your lab partners during the lab to make sure that everyone has all of the observations and measured values in order to fill out the in-class lab worksheet. In exercise 2, you will need to find 4 solutions that are less than 20% concentration. This can be found by diluting the prepared stock solution. The stock solution is 20%, and you will need a 25 milliliter volumetric flask. The stock solution in this lab was pre-made by measuring out an appropriate volume of a pure liquid and diluting it to a known volume. In this case, it was 20% concentration. Stock solutions are diluted by adding more solvent in order to get a solution with a reduced concentration of the solute. In order to find the concentration of the new solution, also called the dilution, we multiplied the initial concentration of the stock solution times the initial volume used and set that product equal to the product of the final concentration of the dilution and the final volume used. The unknown was found then by using algebra. A simplified equation can be described by CI times VI equals CF times VF. Each of the 4 trials, we also found the density and concentrations. We used a similar method as in exercise 1, where we measured the mass of the volumetric flask alone, then added an amount of solution using the pipette. We recorded the volume of the solution in the pipette and then put it into the volumetric flask. We then filled up the volumetric flask to a line that marked 25 milliliters. We used the data from the 4 rounds in order to find their respective densities and final concentrations. Then we graphed the solution's densities and concentrations in order to aid us in exercise 3. In order to find the unknown solution's concentration and density, we used very similar methods as in part 1 and part 2 of the exercise. We found the final mass of the solution, then drew up an amount of the unknown solution into a pipette. We marked down the volume in the pipette. We were able to find the final mass. We found the unknown's density by dividing its mass by its volume, and then we used the graph from exercise 2 to determine the most likely concentration of the unknown density. When you're finished with your lab, make sure to clean all of your instruments that were used and put them away. Also, make sure to wipe down and clean your lab site.